You know, we're all surrounded by this invisible war. It's a constant battle of signals that our entire modern world depends on winning. So today, we're going to pull back the curtain on the science of the invisible shields that protect all our tech.
You've totally heard that, right? That weird staticky buzz that comes out of your speakers just seconds before your phone lights up with a message? Well, that is not a coincidence. It's actually a clue to a way bigger phenomenon that's happening all around us all the time.
The thing is, we are basically swimming in a sea of invisible signals. I mean, every single phone, every laptop, Wi-Fi router, even your microwave, they're all constantly broadcasting electromagnetic waves. And all of that together creates a kind of electronic noise pollution.
So what exactly is this invisible pollution? And, how serious of a problem are we really talking about here?
Well, it's called electromagnetic interference, or EMI for short. The easiest way to think about it is imagine trying to have a quiet conversation in a super crowded, noisy room. That's what EMI is for our electronics. These unwanted signals can totally mess with other devices, making them glitch out or just fail completely. But here's the interesting part. Some research actually considers EMI to be the fourth major type of environmental pollution, right up there with air, water, and noise. And it's even been linked to health issues like headaches and trouble sleeping.
Okay, so if we're living in this constant cloud of electronic noise, how in the world do we protect our sensitive electronics and, well, ourselves from it? The answer is, you build an invisible wall.
And that is the whole idea behind electromagnetic shielding. It's all about creating a barrier, kind of like a high-tech Faraday cage that can stop these waves dead in their tracks. It isolates a device from the noisy world outside, and just as important, it stops that device from adding to the noise itself. But how does a simple barrier actually stop something you can't even see? I promise it's not magic, it's just really cool physics. There are actually three powerful secrets, three mechanisms that make it all work. Let's break them down.
First up, we've got reflection. So imagine the shield is like a bouncer at a super exclusive club. The electromagnetic wave shows up, but the shield's material is just so different from the air it was traveling through. It's what's called an impedance mismatch. Basically, the wave hits this wall and just can't get in. So this mismatch forces most of those waves to just bounce right off. Entry denied.
But, what happens to the few waves that do manage to sneak past the bouncer? Well, that's where absorption comes in. The material of the shield then acts like a really dense sponge. It just soaks up the energy of the wave as it tries to pass through. And that energy doesn't just vanish. It gets converted into a tiny, totally harmless amount of heat.
And finally, there's a third really clever trick: multiple reflections. This happens in materials that have a lot of internal surfaces, like special foams or composites. Any wave that gets inside gets trapped. It starts bouncing back and forth like a pinball in a pinball machine. And with every single bounce, it loses more and more of its energy until it just fades away into nothing.
So the key takeaway here is that a shield's total power comes from all three of these things working together. It's a bouncer, a sponge, and a pinball machine all rolled into one. And that combination is what creates such a powerful defense against all this invisible interference.
Now, when I say shield, you're probably picturing a big, clunky metal box, right? And yeah, for a long time, that's pretty much what shielding was. But oh man, materials science has come a really, really long way.
The old-school shields made of metals like copper or special alloys are super effective, for sure. But they're also heavy, they're rigid, and they can rust. The new generation of shielding materials are these awesome polymer composites. They're incredibly lightweight, they're flexible, they don't corrode, and that opens up a whole new universe of possibilities.
And this just gives you a little peek into the wild new toolbox scientists are playing with. We're not just talking about big sheets of metal anymore. They're working with these incredible nanomaterials, like graphene and carbon nanotubes. By literally engineering materials at the molecular level, they can make shields that are thinner, lighter, and way more effective than anything we've had before.
So, we have the science, we have these amazing new materials. But why does any of this actually matter in the real world? Let's take a look at how this tech is, quite literally, shielding our future.
I mean, why do we pour so much money and research into stopping something we can't even see? Well, what this really means is that without effective shielding, a huge amount of our modern technology just couldn't work, at least not safely.
And we're talking about incredibly high stakes here. In aerospace, shielding is what protects critical flight computers from failing mid-flight.
For the military, shields that are great at absorption are the secret sauce behind stealth technology. In our hospitals, shielding protects pacemakers and MRI machines from life-threatening interference. And yeah, right in your own home, it's what lets your laptop, your phone, and your smart speaker all exist in the same room without driving each other crazy.
And don't get it twisted, this is huge business. The global market for these invisible shields was already worth more than $6.5 billion back in 2020, and that number is just exploding as our world gets more and more connected.
So this leaves us with a pretty fascinating challenge, doesn't it? The very same signals that connect our world and make all our tech smart are also potentially their biggest threat. So the race to find better, lighter, more perfect shielding materials, that's not just some niche engineering problem. It's fundamentally about making sure our digital future is stable, safe, and reliable.